So one of the things I've been meaning to do is just do a quick update in terms of, I guess, the entire workflow for how I capture input lag is done. And so what I thought I would do is use a recently released game, Modern Warfare, to pretty much go from start to finish, working through the whole thing. Throw that up on YouTube, and then I'm sure I will get some feedback or questions or helpful comments. So starting at the beginning, this is my testing box. This is all made by myself. The setup is reasonably simple, straight up little box that I've modified. I have 3D printed some buttons for the front, and I've used some keyboard keys there, just so that I've kind of got all of the PlayStation buttons, including like the L3, L3, R3, the start, select, etc., because it just gets a bit of a pain if you don't have everything available. I've got a Brook Universal fighting board inside there, and so that's the PCB I use for this. It works with PC, PS3, PS4, Xbox One, Xbox 360, as well as some other formats. I believe Mega Drive Mini. It works with the PlayStation Classic and so forth. So there's a lot that you can do with that. It's incredibly quick, and so I kind of use it as I guess a comparator between different formats and a baseline for assuming it's one of the fastest ones out there. You can see here I've just got a standard Arduino, and on top of that I've got my own printed circuit board. There's a bit going on there. I've got a GPS module. In the future, what I want to do is to try to use that to test network. So there's a ping per second function, which every second sends out a signal for 100 milliseconds and then off for 900 milliseconds. And I should be able to use that to kind of, I guess, sync inputs across different locations. There are 3 pins here, which basically just send out a signal. The first and second turn on for the 100 milliseconds, off for the 900. And then the third one does the inverse. So it's on for 900 milliseconds, off for 100 milliseconds. First one's just hooked up to an LED, so with cameras we can see what's going on. More interestingly, the second one hooks up to this optocoupler or optical isolator. All that does is that when a signal comes through here via the resistor, it will basically turn on or off these channels and do it with electrical isolation, so there can't be any crosstalk or any suggestion of that. It's got 4 channels here across 8 pins, and so you can do 4 different devices at once. So what I'll do is have this hooked up to my controller, to the button that I want to test. You can see here I've just brought out some leads from the Universal Fight board, so I can hook onto those. And every time the signal comes through here, it just completes the circuit and the button is pressed. I do the opposite with my video signal, just because it's easier to interpret that way. And so if you kind of follow it up here, you can see I've just got some RCA connectors. The red one, so the blue and the green are connected normally at the moment. The red one is hooked up to the PCB there, and so when the button is being pushed, the video signal will be being cut. There's nothing special about these converters. I bought them off eBay from a local company. They convert 1080p 60 to component nice and easily, and the point is it's very difficult to interrupt the video signal of an HDMI cable or output, but once you've converted it to component, it's very easy to do so. I've tested these multiple times. There doesn't appear to be lag from multiple different ways of interpreting that, and so I'm happy enough that that's not throwing the results off or anything like that. So that's fairly much it. That's my testing setup for the moment. The next thing I'll do is get a game running and show you how I capture from there.